Unit 1 Linux File Operations. Overview. This unit introduces the foundational skills needed for effective Linux system administration, with an emphasis on Red Hat Enterprise Linux, RHEL. It covers command line proficiency. Mastery of the shell environment is essential for routine tasks such as navigating the file system, managing processes, and automating scripts. Text editing with 6/vim. Given that many RHEL systems use 6/vim as the default editor for configuration and scripting, learners are introduced to these tools through practical exercises like using VimTutor and exploring interactive resources such as the Adventures. Understanding the Linux file system. The worksheet emphasizes the standard Linux file hierarchy, critical for managing files, permissions, and services in a Red Hat environment. Basic utilities and system management. Along with the command line and text editors, the unit touches on fundamental utilities that are pivotal for system configuration, troubleshooting, and maintenance on enterprise systems. Learning objectives. Master command line fundamentals. Develop proficiency in navigating the Linux command line interface, CLI, for everyday system management tasks. Learn how to execute commands to manipulate files, directories, and system processes efficiently. Understand the Linux file system. Grasp the structure and organization of the Linux file hierarchy. Comprehend how the file system affects system configuration, security, and troubleshooting on Red Hat platforms. Gain proficiency in text editing with 6/vim. Acquire hands-on experience with 6/vim through guided exercises, e.g. VimTutor, Adventures. Learn to edit configuration files and scripts accurately, which is critical for system administration. Engage with practical system administration tasks. Explore foundational utilities and commands essential for managing a Linux system. Apply theoretical knowledge through real-world examples, discussion posts, and interactive resources to reinforce learning. These objectives are designed to ensure that learners not only acquire technical competencies, but also understand how these skills integrate into broader system administration practices in a Red Hat environment. Relevance and context. The skills taught in this unit are indispensable for several reasons. Efficient system management. The RHEL environment is typically managed via the command line. Proficiency in the CLI, along with an in-depth understanding of the file system, is crucial for daily tasks like system configuration, package management, using tools such as Yum or DNF, and remote troubleshooting. Security and stability. Editing configuration files, managing system services, and monitoring logs are all critical tasks that ensure the secure and stable operation of RHEL systems. A robust understanding of these basics is necessary to mitigate risks and ensure compliance with enterprise security standards. Professional certification and career growth. For those pursuing certifications like the Red Hat Certified System Administrator, RHCSA, or Red Hat Certified Engineer, RHCE, these foundational skills are not only testable requirements, but also a stepping stone for more advanced topics such as automation, using Ansible, container management, with Podin or OpenShift, and performance tuning. Operational excellence. In enterprise settings where uptime and rapid incident response are paramount, having a solid grasp of these fundamentals enables administrators to quickly diagnose issues, apply fixes, and optimize system performance, thereby directly impacting business continuity and service quality. Prerequisites. The unit assumes a basic level of computer literacy, meaning the learner is comfortable with fundamental computer operations. However, before achieving that level, one must have digital literacy. This involves familiarity with computer hardware, understanding what a computer is, how to power it on-off, and how to use basic peripherals, keyboard, mouse, monitor. This foundational comfort enables users to interact with a computer effectively. Basic software navigation. Knowing how to use common applications like web browsers, file managers, or simple text editors. This prior exposure helps learners transition into more specialized areas, like command line interfaces, without being overwhelmed. Understanding core concepts. Grasping the basic idea of files, directories, and simple interactions with the operating system lays the groundwork for later learning. Without this, even basic computer literacy may be hard to achieve. Key terms and definitions. Linux kernel. Command line interface CLI. Shell. Terminal. File system hierarchy. Package manager, e.g., yum/dnf. Text editors, 6/vim. Sudo. File permissions and ownership. Processes and daemons. System logs. Networking basics. Bash scripting. Worksheet number 1. Linux file operations. Instructions. Fill out the worksheet as you progress through the lab and discussions. Hold your worksheets until the end to turn them in as a final submission packet. Resources/important links. What is Vim? Vim is a free, open source, and highly configurable text editor. Vim includes multi-level undo, syntax highlighting, command line history, online help, spell checking, file name completion, block operations, script language. There is also a graphical user interface GUI available. This editor is very useful for editing programs and other plain text files. Be aware what the Linux Foundation is and how to use the Linux command line interface. The worksheet has been provided below. The documents can be transposed to the desired format so long as the content is preserved. For example, the .txt could be transposed to a .md file. Continue your learning through this recording. Unit 1. Great job! You should have spent close to 50 minutes learning and working through this worksheet. After you are finished with this, feel free to continue to the discussion posts. Discussion post number 1. Using a 0 to 10 system, rate yourself on how well you think you know each topic in the table below. Next, answer these questions here. What do you hope to learn in this course? What type of career path are you shooting for? Discussion post number 2. Post a job that you are interested in from a local job website. Link or image. What do you know how to do in the posting? What don't you know how to do in the posting? What are you doing to close the gap? What can you do to remedy the difference? Submit your input in the link below. Start thinking about your project ideas. More to come in future weeks. Topics: System stability, system performance, system security, system monitoring, Kubernetes, programming/automation. You will research, design, deploy, and document a system that improves your administration of Linux systems in some way. Definitions: Kernel, Kernel ARGS, OS version, modules, mount points, text editor, digging deeper. Use VimTutor and see how far you get. What did you learn that you did not know about 6/Vim? Go to vimadventures.com and see how far you get. What did you learn that you did not already know about 6/Vim? Go to YouTube too and see how far you get with Vim. Lab number 1. Linux file operations. The lab has been provided for convenience below. Required materials. Rocky 9.4 or comparable Linux box. Root and/or sudo command access. Pre-lab warm-up. Exercises. Warm up to quickly run through your system and familiarize yourself. Ask yourself, what does this do differently? Can you figure out what the size of those files are in bytes? What command did you use? What do each of these values mean? Mandate to figure those values out. Lab test tube. This lab is designed to help you get familiar with the basics of the systems you will be working on. Some of you will find that you know the basic material, but the techniques here allow you to put it together in a more complex fashion. It is recommended that you type these commands and do not copy and paste them. Word sometimes likes to format characters, and they don't always play nice with Linux. Working with files. Let's begin. Creating empty files with touch. You will see that fruits.txt exists and is a 0-length bytes file. Take a look at those values and see if you can figure out what they mean. Next, creating files just by stuffing data in them. What is the difference between these two? Appending a file, too, adds to the file, whereas a single greater than sign just overwrites the file each write. Log files almost always are written with 2. We never use a single over those types of files. Creating file with 6 or vim. Try this and follow the code as intended. Please be careful while reading the syntax. Look at what happened in each of these scenarios. Can you explain the difference between CP and MV? Read the manuals for CP and MV to see if there's anything that may be useful to you. For most of us, R is a tremendously useful option for moving directories. Searching/filtering through files. Please read and follow as intended. If need be, please pause the video. We'll continue on from here. Can you figure out why that worked? What do you think the caret does? Anchoring is a common term for this. See if you can find what anchors to the end of a string. Sorting files with sort. Please read and follow as intended. If need be, please pause the video. We'll continue on from here. Advanced sort practice. Read man to see why that works. Why do you suppose that it needs to be reversed to have the highest numbers at the top? What is the difference, if you can see any, between using the n or not using it? You may have to use head -40 to figure that out, depending on your processes running. Read man ps to figure out what other things you can see or sort by from the ps command. We will examine that command in detail in another lab. Working with redirection. The good thing is that you've already been redirecting information into files. The N are useful for moving data into files. We have other functionality within redirects that can prove useful for putting data where we want it, or even not seeing the data. Catching the input of one command and feeding that into the input of another command. We've actually been doing this the entire time. Is the pipe operator and causes the output of one command to become the input of the second command. Please look at the code and read appropriately. We will be continuing shortly. See if you can figure out what each of those commands do. Read the manual man command for any command you don't recognize. Use something you learned to affect the output. Throwing the output into a file. We've already used n to throw data into a file, but when we redirect like that, we are catching it before it comes to the screen. There is another tool that is useful for catching data and also showing it to us, that is T. Do a quick man on T to see what that does. Try it without that value. Can you see any other useful options in there for T? Take your time, review the code. We will continue here. Pause the video if you need more time. ignoring pesky errors, or tossing out unwanted output. Sometimes we don't care when something errors out. We just want to see that it's working or not. If you're wanting to filter out errors too, in the standard error, you can do this. Read this over. Pause the video if need be. Continuing. In one of our later labs, we're going to look at stressing our systems out. For this, we'll use a command that basically just causes the system to burn CPU cycles, creating random numbers, zipping up the output, and then throwing it all away. Here's a preview of that command so you can play with it. May have to why install bzip2 for this next one to work. Do you notice anything? Use trtl plus C to break if you use that, and it becomes too long or your system is under too much load. The only numbers you can play with there are the 1024K and the count. Other numbers should be only changed if you use man to read about them first. This is the poor man's answer file. Something we used to do when we needed to answer some values into a script or installer. This is still very accurate and still works, but might be a bit advanced with a lot of advanced topics in here. Try it if you'd like, but don't worry if you don't get this on the first lab. Pause here and read the code. What happened here is that we read the input from command line and gave it in order to the script to read and then output. This is something we do if we know an installer wants certain values throughout it, but we don't want to sit there and type them in, or we're doing it across 100 servers quickly, or all kinds of reasons. It's just a quick and dirty input hack that counts as a redirect. Working with permissions. Permissions have to do with who can or cannot access, read, edit, write, or execute files. Permissions look like this. The primary permissions commands we're going to use are going to be chmod, access, and chown, ownership. A quick rundown of how permissions break out. Let's examine some permissions and see if we can't figure out what permissions are allowed. The first character lets you know if the file is a directory, file, or link. In this case, we are looking at my home directory. Answer these short questions below. RWX. For UID. What permissions do I have? For group. Who are they? What can my group do? For everyone else. What can everyone else do? Go find some other interesting files or directories and see what you see there. Can you identify their characteristics and permissions? Be sure to reboot the lab machine from the command line when you are done. Bonus for Unit 1 VIM Fundamentals for Linux sysadmins. Module 1. Getting started, days 1 to 2. Day 1. First contact with VIM. Segment 1. The basics. Complete first section of vimtutor. Learn essential commands. Vim filename open/create file. I enter insert mode before the cursor. A enter insert mode after the cursor. Escape return to normal mode. W save changes. Q quit. WQ or ZZ save and quit. Q quit without saving. Segment 2. Building muscle memory. Create 5 different files. Practice mode switching 50 times. Write and save content in each file. Practice recovering from common mistakes. Accidentally press keys in normal mode. Forgot to enter insert mode. Trying to quit without saving. Segment 3. First real task. Create a simple bash script template. Add standard sections. Shebang line. Comments. Basic variables. Simple functions. Save and reopen multiple times. Day 2. Comfort zone. Segment 1. More basic operations. Complete second section of vimtutor. Practice quick save and exit combinations. Learn to read VIM messages and errors. Understand modes in depth. Normal mode. Insert mode. Visual mode, introduction. Segment 2. Error recovery. Create deliberate errors and fix them. Write without insert mode. Exit without saving needed changes. Get stuck in different modes. Practice until you can recover without thinking. Segment 3. Real config practice. Copy /etc/hosts file. Make various modifications. Add new host entries. Modify existing entries. Add comments. Save different versions. Module 2. Navigation, days 3 to 4. Day 3. Basic movement. Segment 1. Core movement commands. Master the basics. Read this. Do you understand? Pause if needed. Segment 2. Movement drills. Create a movement course file. Practice moving between marked points. Time your navigation speed. Compete against your previous times. Segment 3. Applied navigation. Navigate through /etc/ssh/sshd_config. Find specific settings. Move between sections. Locate comments. Jump to line numbers. Day 4. Advanced movement. Segment 1. Extended movement. Learn efficient jumps. Read this. Do you understand? Pause if needed. Segment 2. Speed training. Work with a large configuration file. Practice jumping between sections. Find specific lines quickly. Navigate through code blocks. Segment 3. Real-world navigation. Work with system logs. Jump between error messages. Navigate through long configuration files. Practice quick file browsing. Module 3. Essential editing, days 5 to 7. Day 5. Basic editing. Segment 1. Edit commands. Master core editing. Read this. Do you understand? Pause if needed. Segment 2. Editing drills. Create practice documents. Delete and replace text. Copy and paste sections. Practice undo/redo chains. Segment 3. System file editing. Work with /etc/stab copy. Add mount points. Remove entries. Comment lines. Fix formatting. Day 6. Intermediate editing. Segment 1. Combine commands. Learn efficient combinations. Read this. Do you understand? Pause if needed. Segment 2. Practical application. Edit service configuration files. Modify system settings. Update network configurations. Clean up log files. Segment 3. Speed challenges. Timed editing tasks. Configuration file cleanup. Quick text transformation. Error correction sprints. Segment 1. Advanced operations. Read this. Do you understand? Pause if needed. Segment 2. Integration practice. Combine all learn commands. Work with multiple files. Practice common scenarios. Time your operations. Daily success metrics. By end of each day, you should be able to: Day 1. Open, edit, save, and exit files confidently. Day 2. Understand and recover from common errors. Day 3. Navigate small files without arrow keys. Day 4. Move through large files efficiently. Day 5. Perform basic edits without hesitation. Day 6. Combine movement and editing commands. Day 7. Edit configuration files with confidence. Practice tips. Use Ventutor during breaks. Disable arrow keys completely. Keep a command log of new discoveries. Time your editing operations. Practice with real system files, copies. Remember, focus on accuracy first, then build speed. Thank you for watching. We will continue on to Unit 2 in the next video. If you have any questions, don't hesitate to Go to the Discord and ask questions in the appropriate channels. We wish you the best on your completion of this course.